All right, today I decided to do something a little bit different. I want to talk about the vision of blockchains, what we're doing here, something that I think a lot of you and us are wondering about. What's the use of this? What is it useful for? And I want to do it through telling a story, by doing a narrative through maybe a few pictures and a story. So this talk is not going to be super technical or super scientific. I want to start with a story of construction, something different from blockchains, how people build buildings, how people build buildings through history, starting with prehistory. Hunters and gatherers used their biological instincts to find dwellings. They made caves, they used branches to build their houses and protect themselves from the cold winter. That's the instinctive stage of building buildings. When the agricultural revolution arrived and people grew to communities of more than 20 and 30 in tribes, but to the thousands, then they needed to invent new technology. So instead of using their biology and their instinct to build, what they did is they invented technology that required some sophistication. Materials like bricks and the technology to make them, like furnaces to bake them. And this technology was invented through trial and error, and was passed from generation to generation, from master to journeyman to apprentice. This is the craftsmanship stage. Today, we have the marvel of the New York City skyline, in which we use scientific methods and professional expertise to build buildings that are standing many, many stories high, the high rises of New York. This is the scientific stage of building. So technology evolves from instinctive stage, using our biology, to craftsmanship, trial and error, and passing knowledge from generation to generation, to the scientific stage in which we make things precise and use the predictive power of science. Now a different story. A story in our science, the science of trust. Well, maybe you have not heard of blockchain science and blockchain engineering in these terms, but this is the problem that we're solving. Going back to prehistory, people had to survive the cold winters in a different way, not just building houses, but managing their economies. And I use the word economy in a very broad sense. How do you manage resources? How do you find who is trustworthy? How do you make sure that you will have enough food for the winter? And in this stage, people used again their biology. In tribes of 20 or 30, this is easy. We gossip about who is trustworthy and who is not. Alex is a trustworthy hunter. He will bring back game. Maria is a gatherer, but she's not very trustworthy. Maybe she gets sick, maybe she's lazy. This is communicated through gossip and through a social fabric of biology. Then people moved to larger settlements of thousands of people, and the biology was not sufficient because people could not hold 1,000 people in their heads. So now they had to invent new technology to manage trust to their fellow humans. These inventions were institutions. They didn't use materials such as bricks and stones, but they used institutions such as money to keep track of favors. How much did I do? How much did the other person do? How much do I owe them? They used other institutions such as laws to make sure that they can trust strangers to do the right thing, or else. This required people to have a permanent record of things, what has happened, a list of transactions. This is an Incan quipu. They are knots tied on a string that are used to keep track of records, things like how much money is owed, how much tax is owed. This is one of the first examples of a permanent record. People were required to do that in order to keep track of whom to trust. So with these inventions, trust now becomes one level of indirection deeper. Instead of wondering whether I can trust my fellow humans, I can do that, but now I need to trust that the record keepers are doing the right thing, the authorities who keep the written record, the scribes and the safekeepers. With the invention of written language, these records were kept in scrolls and big books and ledgers. Today, our world runs completely on ledgers. Everything that we know beyond our basic biology is mandated by whatever is written on books, whether they're fat books in the analog form or fat databases in the backend system of a bank. As we know from our own blockchain science, the first thing that runs on ledgers is banking and finance, keeping track of taxation, money, how much wealth is owned by a person. But a lot of other things run on ledgers. International business, relationships between multiple corporations and agreements between them that are mandated by local and international law. Even government itself, the elections of parliament, the elections of local authorities, voting on laws, voting on a constitution. The reference of what is the truth is with reference to a ledger. Lastly, even the military runs on ledgers. To know what is the hierarchy, whose orders I should follow, we look at these ledgers and these resolve potential disputes. They're the ultimate authority. Recently, I bought a small house here in Athens, and I was actually quite surprised at how close the system resembles some of the things that we're trying to do in blockchains, maybe a bit more inefficiently. The lawyer had to go back to the records in these fat books and find out how did this house change ownership from the 1920s to today, visiting multiple locations, government institutions, and private notaries and notary successors with books referencing other books, referencing other books. Even on the day of signing the contract, the lawyer had to go back to these books to make sure that nothing had changed, to avert a potential double spend by the claimed owner. Everything runs on ledgers. And yet, these ledgers are still inefficient. We cannot do everything with them, and we cannot really allocate resources in the best possible way that we would imagine. One thought experiment. If I own a piece of land in Kazakhstan, and I want to collateralize it to buy an apartment in Manhattan, it's completely impossible today. And the reason for this is not that these resources don't want to be matched, it's a matter of trust. Different authorities manage different resources, and they're mutually distrustful in the international setting. They're also heterogeneous and non-standardized. My claim is that we're still in this craftsmanship stage of trust technology. We have not yet reached the scientific stage of trust technology. This is where blockchains come in. We are envisioning a planet in which we will have a planetary-wide collaboration in which everybody can contribute to the pool of resources, anybody can take from the pool of resources, and people can be matched with jobs, companies can be matched with capital, and international diplomacy can be conducted on a global scale and global level. This will be solved by inventing the scientific stage, and this is where blockchains come in. But why blockchains? Why are they the right tool for the job? Well, I have one primitive example of what we can do today with blockchains from the example of collateralizing and getting a loan. And this is a system called Aave from decentralized finance that is operational today. And in this system, if a person owns a piece of collateral in one token, they can use that collateral to get a loan in a different form. And this system allows people to get a loan in the billions of dollars, get it approved in under a second potentially, without human intervention, all completely automated, and it works across borders and boundaries. So, can we use the system to collateralize land and buy houses? No. But the basic technology is starting to get there. The question is, do we want to put this technology to use for real-world things? There are three reasons why blockchains are the right tool for the job. And I want to go through them. Many of them you've heard before, but I think not everything. The first one is decentralization. Many of my colleagues will tell you that decentralization is a noble goal, it's a political goal, and the purists will tell you that it's important on its own. Maybe that's true, but there are byproducts to decentralization that are more important than decentralization itself. And these byproducts are, first, that decentralization leads to open systems. Because these systems are not designed with one authority in mind or by one authority, they have to be open by design, open source. Anybody can inspect these systems and assess whether they're suitable for them. This builds confidence in distrustful parties. Decentralization makes things transparent. You may agree or disagree with the rules that we're following to run our global economy. Maybe you like capitalism, maybe you like socialism, maybe you like communism, but whatever the rules may be, you need a way to record these, to record that the rules are being followed, and to allow for public verifiability of these rules. And I think nobody will disagree with that. Third, decentralization breeds standardization. Because the systems are open, these are leading to developing standards that are the same for everybody. Today, when you're making a new token in, let's say, Ethereum, this is going to be an ERC20. It doesn't matter if it's this or that token. The nature of it is going to be the same. So we're more interoperable and more standardized. Hopefully, we can do the same with real-world assets that matter in everyday life. Lastly, it breeds permissionlessness. That means removing walled gardens and allowing anybody to participate with very low cost without the burden of licenses and certifications. And this creates healthy competition and a healthy ecosystem. The second part that make blockchains suitable for this is programmability. Programmable money, programmable contracts. In the traditional system, if you want to introduce a way for people to collaborate with each other, you need to create and vote on new laws. But in these systems, you have programming languages like JavaScript or Rust. Or there are smart contract analogs, Solidity and Move, in which anybody can program these rules and create them and propose to a counterparty to participate according to those rules. And those rules are self-enforced, and they're followed in the sense that some people call code as law. Lastly, there is this concept of authority reversal. In the traditional system, you have a log of what is happening, a ledger, a view that my balances are this amount of money or that I own this house. But this log is simply a view of reality and authority which stands behind this law. There are some actors like accountants, lawyers, and notaries who take the ultimate decision on whether this house is yours or not. You need to reference different books, look at them carefully, and reach a decision. The bank might show you a balance, but that balance is a soft commitment by the bank. They may even be able to claw back your money. Here, the ultimate authority is whatever the actors say. In the new system, again, we have a log, we have a ledger of transactions, but we all agree that this is the reference point of what is the truth. That's the ground truth. You can still have actors that are acting upon this log. You can enshrine them with authority to change it, but there is one single point of reference, which is the truth. That turns out to be a very powerful idea. The reason is that by reference to the log and by programming it, you can consume these resources in a very efficient manner because you don't need the human aspect of checking their veracity. The log is the reference. These three aspects of authority reversal, programmability, and openness enable the creation of new resources and new ways of dealing with money and with human trust. One example is flash loans that would not be possible unless we had this authority reversal. We know exactly where the money is, unless things were programmable and unless things were transparent and open. In all of this, there is a role of science, which allows us to go from the craftsmanship stage to the scientific stage. When this happened to construction technology, it was science that enabled us to go from one to the next. It came with one man that gave rise to, well, to the inevitable course of history that enabled the skyline of New York, and that is Isaac Newton. He invented calculus and the laws of motion. He used the methods of science. First, he systematized what his predecessors were doing with their hands. Building houses, what makes a house stand. He quantified these things by writing them down in precise equations that could calculate things exactly. And lastly, he used the predictive power to try to predict whether a building that was never constructed before would stand or fall. There was a challenge for Newton, and that was the translation of his science to the application of engineering. Imagine this man who worked through a pandemic in Oxford and Cambridge to come up with these equations. How could he get to the builders that were learning from their masters and their journeymen, the apprentices who spent all their lives building with their hands? How could he convince that the scribbles on a whiteboard make any sense? This took centuries. Throughout history, few were given the power to control the destiny of their fellow humans. Today, we are at a crossroads. As blockchain scientists and engineers, we're given the unique opportunity to shape the planetary economy. We're developing this new science called blockchain science. We are following the same methods and principles that Newton followed in his own science. First, we systematize what the system is giving us through its inheritance. We're trying to find out why these laws exist and why these structures exist, and to codify them into precise algorithms. We use computer science to understand the computational nature of these things. What is the role of a physical signature? What is the role of a contract? What is the role of each authority? Is it required? Is it not? Can somebody game the system? We make these things precise and put numbers onto them. We give definitions. We define quantities such as resilience. What percentage of resources or the population can be adversarial and the system can still survive? Lastly, we try to make predictions. We try to design systems that were never tested in practice and to assess whether they will stand or they will fall. We face again the translational issue. How do we translate from the scribbles on a whiteboard to the engineering and application of the people who are building these systems? Even more, how do we convince the regulators, the lawyers, the people who run the world to adopt these systems that are better? And hopefully this will take less than centuries now that we have the internet. But looking ahead, many of my colleagues will tell you, we have the technology, we have blockchains. It only remains to be adopted by regulators. I couldn't disagree more. I think there are so many open problems, and Nicola's panel will address, I think, some of the open problems. And I want to present 3 pillars in which these problems can be categorized: scalability, interoperability, and usability. First, scalability talks about scaling the system to handle the transactions of the whole economy, whether they're private or public, and these can run in the millions or billions of transactions. And we want our systems to handle these transactions in the same efficiency that they would handle just having 1 or 2 transactions. The last 15 years in blockchain research have found this to be a very hot topic. A lot of it has been solved, but a lot of it remains to be solved. A lot of progress have been made, but more work needs to be done. Next, interoperability. Today, we face a system with thousands of different cryptocurrencies. Which ones should we use? How do they interoperate with each other? If I use one, can I translate it to the other? It's unclear. We're looking to build bridges that are connecting these systems in a way that is seamless to the end user. We're envisioning a worldwide ledger, similar to the World Wide Web, in which the user who's using these systems doesn't have to know what chain their resources are being stored in. Lastly, usability. It's a nightmare to use these systems today, let's be honest. This is the most popular wallet in blockchains today, and me and my colleagues are having trouble using them. This is MetaMask, and to use it, you have to understand what mainnet means. You have to understand what is an account and what these scribbles of hexadecimal mean. You have to understand what is different currency like Ethereum with a high volatility. You need to become an expert in these systems even before you start using them. There are stable coins that are dealing with these, but then you need to know their own names and what they mean and what their trust assumptions are. And then when you get to interoperability and bridging, then you have to go through Axelar and Base and wrapped Axelar tokens. Who knows what this all is? The old system has a lot of wisdom. Here's a thought experiment. Imagine somebody who's holding all their assets in their own self-custodian wallet, hardware wallet. They're on a boat, and an accident happens, and the boat sinks. They swim to safety, but they realize also their house caught fire, and everything burned down. What an unfortunate man. In the land of cryptocurrency, all their wealth is lost, and now they have to recreate everything from scratch. But imagine what happens in the traditional system. If this person was carrying with him his passport and his identity, maybe that's lost in the boat, and then maybe even his birth certificate got burned in the house. But somehow he will manage to go back to the bank, go to a judge, get a passport, and get access back to his money. It's a very basic thing. We still haven't solved that. There's many people who are trying to do that, but we're not quite there yet. How do you get your passport back? Just ask a couple of witnesses to come and testify that it's you, and they're held accountable in law that they're not lying. So hopefully this is one example of how far we are from getting these systems to become adopted in mainstream society. To summarize, blockchains are the technology that will enable the next step in trust, building a global planetary economy in which people can bring in their resources and take what they need. Secondly, that's the right answer because they have openness, programmability, and authority reversal. That's what allows for efficiency, and that's what allows for precise predictions on whether these systems will work. Lastly, we're not quite there yet, and we're facing scientific challenges that are quite significant on scalability, interoperability, and usability. I hope you join me in solving these problems in the next few decades. And with this, I'll take your questions. Yes.
Maybe it's personal, but I would add in the scientific challenges reliability.
I think there's a panel after this about what are the open challenges and what's important, and I think there's a lot of discussion there. So hopefully that can be addressed by the panelists maybe.
Yeah, just to continue, because it's one word, so reliability may mean nothing, but in terms of software engineering practices, I think we are in Stone Age in Web3. There are things that are pushed directly in the mainnet, no test. There is no notion of develop, staging, and production something. So all these software engineering practices is like if we forget them, because it's Web 2. So in Web 3 we can do fancy things. But I believe at the end we are caught by reality. And it is, things that cannot happen is when you push something and you see that you forget things. So there is a regression. There is things that happened in the 80s.
For sure. We need to adopt these. And I think this is... I agree. We should, as engineers, adopt the practices of our... whatever we learn from Web 2, we should not throw it in the garbage.
So I see maybe a little bit of a tension regarding the last thing, right? The guy who lost his passport, lost his birth certificate, needs to start from scratch, right? In the current system, it kind of works because that person goes, and there is a human that makes like a soft judgment somehow.
Thanks. And this soft judgment is that this person is indeed Alberto, and then it has a way to punish all the false witnesses that they may have had, right? So this is not easy in terms of blockchains, right? Everything else like scalability, interoperability, and the beginning of usability, I see a tech way forward, but the last one, I do not. Any idea about it?
Yes, I think that's the most difficult challenge here. I think there's a few directions here. One of them is involving human authorities. I think that's the easiest answer. The difference here is that you have a choice. As an end user, you have a choice on whom to trust, how much to trust them, which authorities to trust. And you can opt into that. I hope that there were sane defaults to do that for the average human. Right? I don't mind trusting other humans. I don't mind trusting society. If I want to be a purist and hold my keys, so be it, but I wouldn't opt for that. So maybe we should make systems where this choice is possible.
Yeah, that I think is a very good answer, right? But I think the literature is really poor in that direction. The only thing that comes to mind is a system called KELP, effectively, right? That isn't exactly that, but it kind of allows you to recover if you are fast enough under some assumptions, right? But maybe this is like a blind spot that we're all having, right?
I agree. The question is, how do we reproduce the whole civil law, basically, in blockchains? How do we codify it? How do we write it down in smart contracts? And how do we make it precise? And how do we elect the correct authorities? And I think that's going to be a huge challenge to reconstruct all of that.
Yep.
And to not ignore and throw away the wisdom of the old systems.
Thank you for the talk. Can you give us some insights about latest trends in interoperability other than locking, releasing, and have some magic players called relayers, would you have to trust actually 100% for security?
Yeah, interoperability is a very deep question. I think there's here some researchers like Fotini who's worked on it, myself, Nicolas, many others who have published in the field. And there are solutions that don't require intermediaries for trust. What you're describing is maybe a locking of value, but today we can do general message passing between these systems, define general events that allow one smart contract to call another in a sort of atomic way. And these can be done by, well, the main ingredient to remove trust is what we call a light client. It's a programmable component that runs in one chain and consumes data from another chain. If you can do that, it's similar maybe to what a rollup is using sometimes, and I think the panelists may be speaking about that, but the main idea is that in the same way that your local wallet in your phone confirms what happened on one blockchain, at the periphery, at the terminal level, using the same technology, one blockchain can consume data that is produced in another. It's not difficult to move the data, but it's difficult to authenticate the data, and this authentication can happen by leveraging that technology. This technology evolved in 2018, and today it's starting to become applied and it's starting to become implemented and deployed, and we're starting to remove such authorities. You can always go back to the authority to have maybe a more efficient system, and there are transforms to do that. But we have technology to remove these authorities and to create interoperability. Yeah.
So basically the idea is pushing the logic to the client as with networking kind of, right? You push a lot of logic to the client.
No, you can have the logic running within smart contracts that are operating within the consumer chain itself, and the clients can also be terminals that are not super heavy. So you can choose to push some of this logic, let's say, to the validators, and there are techniques that Fotini here will probably speak about, hopefully, on, for example, zero-knowledge proofs that make it very efficient to verify what is happening across ecosystems. And the burden of the proof falls with the prover who wants to make a claim and a transfer.
All right. Let's thank the speaker one more time. Thank you. Cool.